As we get ready to graph polynomials, we need to look at another part of the graph. We're going to consider the behavior of the polynomial functions as the x-coordinate goes to infinity or negative infinity. What happens on the y-coordinate? And here's some things we're going to determine. So what I did was look at these functions and I said, here's the x values and here's the y values. When x is negative 30, y is 808,946. When it's negative 20, it's 159,496. When it's negative 10, it's 9,846. When it's 0, it's negative 4. When it's 10, it's 9,946. When it's 20, it's 159,696. And when it's 30, it's 809,246. So as x is going to infinity or getting larger here, y is also going to infinity. So the limit for the function x to the fourth minus x squared plus 5x minus 4 as x goes to infinity is infinity. Now, as x is going towards negative infinity, or in this case to the left on this table, well, it looks like y is also going to infinity. So the limit as x goes to negative infinity is also positive infinity. For this graph, again, I did x and the y. Negative 30 is negative 728,999,114. For negative 20, it's negative 63,999,544. For negative 10, it's negative 999,934. For 0, it's a negative 4 again. For 10, it's negative 999,934. For 20, it's negative 63,999,664. And I don't have room to put the positive 30. But it does appear here as x is going to infinity, it appears that y is going to negative infinity. So the limit as x goes to negative infinity of negative x to the 6th plus x squared minus 3x minus 4 is negative infinity. And as x is going to negative infinity, it looks like y is also going to negative infinity. So another one to try, we have 3x to the third minus x squared plus 2x minus 4. So x and y again. Negative 30 gives me negative 81,964. Negative 20 gives me negative 24,444. Negative 10 gives me negative 3,124. 0 gives me negative 4. 10 gives me 2,916. 20 gives me 23,636. And 30 gives me 80,156. So as x is going to infinity, it appears that y also goes to infinity. So the limit as x goes to infinity is infinity, and as x is going to negative infinity, it appears that y is also going to negative infinity. Good. We have negative x to the 7th plus x minus 4. So here's my x, here's my y. I'm going to start with negative 20, and that's 1,279,999,976. Negative 10 is 9,999,986. 0 is negative 4. 10 is negative 9,999,994. And 20 is 1,279,999,984. So as x is going to infinity, whoops, this was a negative, y is going to negative infinity. And here, as x is going to negative infinity, y is going to infinity. So they're their opposites. Well, it turns out you're studying this for all first-degree polynomial functions, ones that just linear equations. The end behaviors like x equals y, where if x goes to infinity, y goes to infinity, and x goes to negative infinity, so will y. Or y equals negative x, where they'll be reversed. All second-degree polynomial functions have end behavior like a parabola, so that each both go to infinity or to negative infinity. Third-degree polynomial functions have end behaviors like y equals x cubed, which you may remember looks something like this. Y equals negative x cubed looks like this. And so on. So it turns out the end behavior is determined by the degree and the sign of the very first term, which might be why we're talking about the leading coefficient test. And that will bear similar to the 4 samples I just did.